Welcome to Mrs. Miller's notes for her pre-calculus class. These are the notes for section 7.1, day 1, entitled Trigonometric Identities. And in chapter 7, we're still going to keep talking about trig identities and trig expressions. And today we're going to focus on how we can simplify trigonometric expressions. And most of what's displayed in this table we've worked with before. We know our reciprocal identities. We know the Pythagorean identities. We've even talked about the even and odd identities. Most of the time we just use the all students take calculus shortcut to help us remember when sine and cosine and tangent are positive or negative. But that's basically what the even and odd identity does as well. So this part at the bottom of the table, these co-function identities, these are new, and we're going to use them more as we go through the chapter. And basically what this is, it's a pretty cool shortcut or observation. And I say if you take sine of pi over 2 minus something, minus some angle, it will be the same as the cosine of that angle, that something. So remember, pi over 2, that's 90 degrees. Okay, so let's just say that, as a little side here, let's just say that u is 30 degrees. Okay, so then I would have sine of pi over 2 minus 30 equals cosine of 30. Okay, so pi over 2, that's 90, minus 30 is 60. So this is really sine of 60 equals the cosine of 30. Now if you think back to your unit circle, think of that first quadrant. Sine of 60 was square root 3 over 2, and cosine of 30 is also square root 3 over 2. Okay, so these co-function identities are just a really cool observation that old dead math people made. And they come in handy to help us simplify bigger angle measurements that maybe aren't on the unit circle, but we can break them apart to be values that are on the unit circle that we know the values for. So we'll come back to those more later. But what we're going to do today is we're going to simplify trig expressions. And basically, we want to take big, complicated expressions and rewrite them in a much simpler way. And we're actually going to use algebraic techniques to do that. So we're going to use some of our knowledge of our identities, those inverse identities or the Pythagorean identities. We're going to use that. And then we're going to use some of our algebra skills as well, like common denominators or factoring or breaking apart fractions. So that way when we have really complicated looking trig expressions like this one, we can simplify it all down into something much, much simpler. So we have the cosine of t plus the tangent of t times the sine of t. Now usually they don't write in that little dot for multiplication. So just know that when the tangent t, sine t, when it's all written together like that, know that there's multiplication going on between those two functions. And when you first look at this, you just have to kind of think, okay, what do I know about cosine or about tangent or about sine that can help me start to simplify this and maybe rewrite it a little bit? Now I've got sines and I've got cosines, and then I have this tangent. And we know that tangent is actually sine over cosine. So since I have these other functions that are written in sine and cosine, I'm going to rewrite this so that tangent isn't tangent anymore. I'm going to make it sine of t over the cosine of t. So all I did there was use my knowledge of tangent and rewrite it as sine over cosine. Okay, so now basically I have two terms. I have one on the left side here, the cosine t, And then I have this big expression on the right-hand side, the sine t over cosine t times the sine t. Now, those are being multiplied. So if I multiplied them together, I would get sine squared t over cosine t. Okay, so that's a little more simplified. Now I have two terms, or two fractions even if you want. Well, I know how to add fractions. I just have to get a common denominator. So my common denominator would be cosine of t. So this is going to stay. This second fraction is going to stay. But my first fraction, I would have to adjust it. I would have to multiply by the cosine of t. So I would have cosine squared t. Now, cosine squared plus sine squared is 1. So I have 1 over cosine t. And 1 over cosine t is secant of t. So just using my knowledge of tangent and multiplying, finding a common denominator, and then knowing that this is a trig identity, the sine squared plus cosine squared, that's one of my trig identities. And cosine squared plus sine squared is 1. So when I have a common denominator in my fractions, I can add my numerators. All completely legal. Every step that I did to simplify this expression, completely legal mathematical operations. So this is how we're going to take these really big expressions and simplify them down into nicer ones. So they're a little funky at first. When you first look at them, you just kind of have to think, okay, what do I know? What can I do? So you have to think about your bag of tricks, so to speak. You have to think of what knowledge you know, what mathematical skills you have, and you can apply any of them. Okay, so we have a couple extra examples here. These aren't in the book, so these are just extra ones to get you to practice these concepts. So you have extra example A, B, and C, and then we'll be done. Now, if you look at this expression, again, we have terms on the left plus terms on the right. Okay, so a lot of this is being able to view the different terms and how they are grouped together. So we have cosine cubed x. Oh my gosh, we haven't seen that yet, but you can have that. Plus sine squared x times cosine x. And again, there's a little times in there, even though it's not written in. Now, if you're looking from one term to the other, hopefully you'll see that they have something in common. And that something that they have in common is a cosine of x. So if they have that in common, I'm going to take it out of both of them like a GCF. So I'm going to take out a cosine of x, which will leave me with cosine squared x. Okay, that's more familiar now than cosine cubed x. And sine squared x. Oh, so then cosine squared x and sine squared x, that's 1. So cosine of x times 1, that's just cosine of x. Nice. Very nice. Very straightforward simplification once we took out that GCF. Okay, let's try this one. We have 1 plus secant squared x over 1 plus tangent squared x. Now, we've seen this before where we're adding 1's to our squared trig functions. So if we look back at this table, let's look at our Pythagorean identities here. Let's see, I had 1 plus secant. Well, and then I also had a 1 plus a tangent. Ooh, right here, this one. Tangent squared x plus 1 is secant squared x. Okay, so that means if I use that identity, I can go back and I can simplify this denominator of the fraction. I'll still have my numerator, 1 plus secant squared x. But this 1 plus tangent squared x, That's secant squared x. So I've simplified this expression a little bit. Some people might argue that it doesn't look as simplified now as it did before, but it's actually more simplified. Okay. Now I have two terms in my numerator and one in my denominator. Now remember, when you're adding fractions, you can write it like this, or you can break it apart so that you have 1 over secant squared x and then secant squared x over secant squared x. So you can give each part of the numerator its own denominator. And doing that, pulling that big fraction apart into two little fractions, helps me simplify both of these parts now. Because 1 over secant, that's cosine. So I have cosine squared x, and secant over secant, that's 1. So I have cosine squared x plus 1. Now, we do want to double check those Pythagorean identities again. Let's see, sine squared plus cosine squared equals 1. If I moved the 1 and the cosine together, either the cosine would be negative or the 1 would be negative, depending on how we moved them. So here where I have the cosine squared x plus the 1, that's as simplified as I can get it. I can't rearrange them anymore so that I could maybe set it equal to sine squared x or negative sine squared x. Not going to happen. That's as simplified as I can get this expression. So again, I'm using my Pythagorean identities from my knowledge of trigonometry, and then I'm using some fraction skills to help me, in this case, break apart a big combined fraction. Okay, so let's try one more. I have sine x over cosecant x plus cosine x over secant x. So again, these are two fractions. Now sine over cosecant, that's not really anything. If it was sine over cosine, I'd have tangent and we'd be in business. Okay, so, but I know cosecant is something. Cosecant is really the inverse of sine. So here's how I'm going to approach this one to kind of think through it. What if I took this fraction and kind of broke it apart into its numerator part and its denominator part? And by that, I mean, what if I rewrote it as sine of x over 1 times 1 over cosecant x? If we multiply fractions, we multiply straight across. So if I did multiply these straight across, I'd still get sine over cosecant, which is what I started with. So all I did now was break them into their little individual pieces, a numerator piece and a denominator piece. Now the numerator piece is fine. I like sine of x. Sine of x is okay. But this cosecant x, 1 over cosecant, that's the same as sine of x. So then this will simplify down into sine squared of x. Oh, okay. Well, let's see if we can do that for the other fraction. If I broke it apart, I would have a numerator piece and a denominator piece. Now cosine is fine. I don't mind cosine. And 1 over secant, that's really cosine. And now cosine times cosine is cosine squared x. And now I know sine squared x plus cosine squared x, that equals 1. That's one of my Pythagorean identities. So the tricky part with this concept is for students to think of what legal mathematical operation that they can do to help break apart or combine or uncombine or rearrange these fractions. So I've demonstrated several legal skills here. Okay, we can um, find a common denominator and then add across the numerator. We can take out a GCF. We can break apart a big fraction into two separate ones. And that's what we did here too. We took one big fraction and we broke it apart into two separate ones. In part B, we were using addition to do that, and in part C, we were using multiplication to do that. So we reviewed some of these essential, basic mathematical simplifications for fractions. Okay, there are others out there that you'll see in the homework as well, but that's probably the trickiest part, just trying to think of what step I can do in order to simplify the expression further. So just keep asking yourself, what can I do to simplify it? How can I get it to look more familiar? Okay, so your homework is page 498, 1 through 25 odd. They're all odds, so that way you can see the answer in the back of the book. Eventually, these will get a little bit nicer because they'll give you the expression to simplify, and then they'll tell you the answer that you're supposed to get. So that way you at least know where you're supposed to get through, so you know how to work towards that answer. So now it's just kind of it's a little free for all. So if you want to maybe peek at the answer and see what you're supposed to get, that could help you to figure out what your steps need to be. But try not to do that too much. Try and think through how you can simplify it first on your own. And remember, the solutions are worked out in the binder in the classroom. And if you have any questions, come on in and see me before school.